Welcome to Table Talks. We are still looking at biology, and specifically we are in for monosaccharides. Earlier on, we have discussed monosaccharides category according to the number of carbon atoms. Let's look in this session category B according to arrangement of atoms. How are atoms arranged? How are atoms arranged? So we can take this that under arrangement of atoms, some take up the aliphatic. Aliphatic means open chain arrangement. Open chain arrangement, or others take up the cyclic format arrangement. Cyclic formatting arrangement. So let's consider an exhaust sugar. Consider an exhaust sugar. Exhaust, as we said, they have C6, H12, or 6. If you consider an exhaust sugar like this, we know there are several examples under here. Fructose is there, galactose is there, and glucose is there. So how are they? If it is open chain aliphatic, if it is aliphatic, that means the carbon atoms, yes, they catenate, but they are not in a cyclic format. There are 6 of them, 6 carbon atoms. If I put here the first oxygen, meaning the others are carrying oxygens. And even this one is carrying 1 hydrogen. So this is the second oxygen. Let's say that is the third, the fourth, the 5th, and the 6th. Then hydrogens will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this structure will obey. So this structure, if it happens in a straight line like that, open chain, we are going to term it as either L, glucose, or D, glucose. L, glucose, and D, glucose. Concurrently, so we, at higher levels of education, we can distinguish even between L series of exhausts and D series of exhausts. But for this, for the purpose now, if you have looked at the drips they put on us when we become C, they are labeled D++ water, meaning that sugar they would have put in that drip is dextrose. So dextrose is glucose, which is called D-glucose. It is a sugar. It is an exhaust sugar. It is glucose itself. So that's why it is not advisable to put on yourself any drip that you have bought glucose from the shop and now you put on, because dextrose has different chemical properties from L-glucose, from beta glucose, as we're going to see. That is open chain. Open chain gives us two isomers, D isomers and L isomers. Remember that isomers have different chemical properties but same molecular formula. You can go to cyclic. Under cyclic, what can we have? We are still considering this. Under cyclic, we can have C, 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 O. If it takes up such a ring, if it takes up such a ring, let's say that is oxygen. If it takes up such a ring, we shall not first of all give it a specific name, but we shall look at the ring and say it has taken up a six-sided ring. And those that take up a six-sided ring, we shall term to them as pyranoses, like a glucose. Glucose takes up a six-sided ring. But still the same chemical formula can still take up another ring. A five-sided ring. There are 6 carbon atoms. Wherever there is a corner, there is a carbon atom, meaning there are 6 of them. Carbon atom 1, 2, 3, 4, 5, 6. This is one oxygen. It can also take up the oxygens CH2 or H, H, O H, 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 O H, H, CH2, O H. So it can take up such a structure. If a sugar takes up a 5-sided ring, then it gets a special name. We are going to term it as a furanose. So that one becomes furanoses. That's arrangement of atoms. Still further, if we come back to the pyranoses, they give us different pyranoses. They give us different pyranoses, which we have to pay attention to. So we can call them pyranoses of glucose. Pyranoses of glucose. So we have said pyranoses take up a 6-sided ring. That's carbon atom number 1, carbon atom number 2, carbon atom number 3, carbon number 4, carbon atom number 5, that is oxygen, that is carbon atom number 6. If we have 12 of them, carbon atom number 1, number 2, number 3, number 4, number 5, number 6, because number 6 is here. So what can separate pyranoses and we get different pyranoses? The arrangement of hydrogen and hydroxyl groups in space. How are they arranged? If this is carbon atom number 1, 2, 3, 4, 5, and 6, if hydrogen is in that space and hydroxyl group is in that space, then that is hydrogen, that's hydroxyl group, that's hydrogen, that's hydroxyl group, that is hydrogen, hydroxyl group, hydrogen, hydrogen, hydrogen. Then we shall name this pyranose as an alpha glucose, depending on the arrangement of the hydroxyl and hydrogen groups on carbon atom number 1. Then on this one, if hydroxyl groups are here and hydrogen is here, then the rest we leave them as they are. We leave this as being H, OH, H, OH. This is H, OH, H, H, OH, and that is hydrogen. It called this carbon atom number 1, 2, 3, 4, 5, and 6. Look at the arrangement of the hydroxyl group on carbon atom number 1 and hydrogen atoms on carbon atom number 1. This gives us another name and another isomer together called beta glucose. So you see, arrangement of atoms within the monosaccharide determines even the chemical properties. And because of this, together with others, number of carbon atoms, functional group taken up, carbohydrates are very many. There are various carbohydrates that do exist because there are very many kinds of monosaccharides. So in our subsequent session, we shall now look at how do I identify monosaccharides if they are present in a food substance. Then conclude with uses of carbohydrates, uses of monosaccharides in living systems.